Hello and welcome to another exam paper walkthrough. Today we're looking at another of the aiming for the grade 9 papers. This is the paper 2, the calculator paper. I'm going to be using a fairly old-fashioned emulator just because I can display it easier. The more modern ones are part of a web package, so aren't as easy to use for this purpose. I'll only stick to the functions on that calculator then. So we'll kick straight off. This paper should be out of 80 marks, and it should be 22 questions. I'm just scanning through. I did a paper yesterday, and it said there were 20. Well, the count was wrong on the front of the paper, but no major drama. Okay, so question 1. We've got a solve, and we've got 6x squared plus 5x minus 6 is equal to 0. Not a nice one to start with. Reason it's not nice is neither our x squared coefficient or our number coefficient are prime numbers. So it could be 6 and 1 or it could be 2 and 3. So we've not got a lot to choose from. I'm going to assume that it factorizes, although as it's a calculator paper, it might be using the formula, but we'll try and factorize it first. So for it to factorize, it's either going to go into a pair of brackets that start with, I'll put both versions in and just see. It's either going to go into a bracket with a 6x and an x, or it's going to go into a bracket with a 2x and a 3x. And then that leaves me, either way, I'm looking for two numbers that multiply to make minus 6. And either 6 lots of one number plus the other number multiply together, add together to make 5, or alternatively, 2 lots of one of the number plus the other number add together to make 5. So my options are only going to be 6 and 1. And if I do a quick bit of elimination, 6 and 1 or 2 and 3 again. So the only way that I can see it working is, sorry, I should have put a 3 there, is down here with a 9 minus 4, so 3 there and a minus 2 there. So that's going to be my combination. So I'm not going to use that one, so I'm not going to use that one. And then I need to put my minus 2 in the bracket opposite that, and then my 3 in that bracket there, and that will work. Yeah, that works. So I'm actually solving. So to make this bracket 0, x would need to be equal to minus 3 over 2. And to make this bracket 0, x would need to be equal to 2 over 3. Or x is equal to 2 over 3. Okay, and if we go to the mark scheme then, so... and there are lots of other ways you could factorize that. That's my version, which does get a bit tricky when we've got non-prime coefficients, but that's the method I'm familiar with and I use the most often. Okay, so in terms of mark scheme, then we've got a method mark for either a method to factorize or for using the quadratic formula. Second method mark if you've actually got the correct values, and then an A mark for the answers. Okay, question 2 then. So Aaliyah brought a car in the first year she bought the car. It depreciates by a rate of 23% per annum. In the second year after she bought the car, its value depreciated by a rate of 19% per annum. At the end of the second year, the car was worth £10,914.75. What was the value of the car before Aaliyah bought the car? So in effect, whatever the original value was then multiplied by 0. So 23% depreciation is going to be equal to a 77% reduction, which as a multiplier would be 0.77, and then a reduction of 19% is going to be equal to a multiplier of 0.81. So in effect, whatever the original value was times by 0.81 times by 0.77, would be equal to £10,914.75. So x is going to be equal to £10,914.75 divided by those two figures multiplied together. So I'm going to type it in like that into my calculator, and that should give me the right answer for let's do it the fraction first of all, £10,914.75. Just double check I've typed that in right. Divided by 0.81 multiplied by 0.77. And just double check I've typed everything in right. So my initial price of the car was £17,500. Nice round number, so I'm going to assume that that's right. All right. Okay, so what does the mark scheme say? So the mark scheme says the first processing mark is given for the process to find the value of the car at the end of the first year by doing £10,914.75 divided by 0.81, and then the second processing mark for dividing that by 0.77. So I'm going to award myself both processing marks, or actually I'll go P1 indicated there, P1 there, and then A1 for 17,500. Okay, question 3. A and B are points on a centimetre grid. A is the point with the coordinates -7, 6. Point B has point B with coordinates 8, -5. Work out the length of AB, giving your answer correct to 1 decimal place. Okay, so this is Pythagoras on a kind of an awkward scale, but it works exactly the same. So I'm going to say that AB squared. Actually, I'm going to be. Yeah, we'll go a little bit more extreme. So I'm going to go the square root of, and then I'm going to subtract my x values from each other. -7 -8. No, not minus. No, that will be fine. Squared plus, and then my y coordinates subtracted. 6 minus 5 squared. And I can, in theory, go to my calculator straight away at this point. So, yeah, just double checking I'm happy with what I've written there. Yeah, that works fine. Right, so I'm going to go to my calculator and then say I'm looking for the square root of, put in brackets, -7 -8, which will give me -15. But when I square that, that will become positive. Plus 6 plus 5 squared. So that should be my answer. So it asks for 1 decimal place, but I'm going to write it in third form first of all, and then I'll go decimal form. So SD. So I'm going to go 18.6010 ... to indicate that I've not rounded, I've just started listing the numbers. And then I'm looking for 1 decimal place, so I'm going 18.6. Okay, and the marks are awarded for, let's have a look. So M1 mark is given for the method to use Pythagoras' theorem to work out the length. So we've got an M1 there. And then it's just an A1 for the answer. There we go. Okay, and question 4. So points on A, B, C, D are points on the circumference of a circle of centre O. A, D, E, and B, C, E. So let me just get that in my head. A, D, E. And B, C, D are on a straight line. Work out the size of angle CDE. So I'm going to mark that on first of all. So CDE is going to be that angle there, and I'll call that X for now, just to help me with my working. Right, let's have a look then. Work out, give reasons for your answers. So I'm going to go, just sort of planning it in my head. I'm going to work out that angle there. So I'm going to say that BAD is going to be equal to 132 divided by 2. It's going to be half of this angle. So that's going to be equal to 66. See the moment again. 66, yeah. And the reason for that is angle at circumference is twice angle at center. So technically angle from a chord or angle from 2 points. If we were calling it a chord, that would be a chord. So angle from a chord Let me just, no. From a chord, angle at center is twice angle at circumference. So I have, for any of these reasons in question, I tend to show my reason, well, show my working and then explain it in a bracket at the side. And then from there, I can then say that that angle there, so BCD, would be equal to 180 minus 66. And that 6 isn't very well drawn. So that's going to be 114. Again, double check on your calculator for all of these. Yeah, and the reason for that is opposite angles of a cyclic quadrilateral. So this is a cyclic quadrilateral, a quadrilateral within a circle. So opposite angles of a cyclic quadrilateral add up to 180. So opposite angles in a cyclic quadrilateral equal 180 degrees. And we're nearly there then. So I'm then going to say that this angle here, which is DCE, technically speaking, I could say that, so I could go, if I wanted to, I could say that this angle here would be equal to this angle minus 16, because the exterior angle of a triangle is equal to the sum of the opposite two interior angles. But yeah, I'll do a second step. So I'm going to go DCE is equal to 180 minus 144, which is going to be equal to 66, and that's angles on a straight line. A line equal 180. And then finally, I'm going to say that the angle that I'm after, CDE, is going to be equal to 180 minus 66 minus 16, which is going to give me 118. So 180 minus 66 minus 16 is 98. Yes. Yeah. Yes, of course. 98. And the reason for that is angles in a triangle equal 180. Angles in a triangle equal 180. So I'm going 98. Right. And if we go to the mark scheme for that, then yeah. Okay, so we have got two method marks, an A mark and a C mark. So let's go. M1 for finding the 66, M1 for finding 114, and then M1 for finding 98. Sorry, A1 for 98. And it says, this mark is given for correctly stating both circle theorems. The angle at the center of the circle is twice the angle at the circumference, and opposite angles of a cyclic quadrilateral add up to 180. So we've got both of those there. Okay, and question 5. This diagram shows two similar solid triangular prisms, A and B. Okay, so yeah, right angled triangle prisms. The volume of A is 58.806. The volume of B is 1587.762. The cross section of each prism is a right angle triangle. for prism B, the area of the base of the triangle is 81. The area of the triangle is such and such. The height of the triangle for prism A is h. Find the value of h. Okay, so we're going to have a couple of stages to this. We're going to use the volume to work out the volume scale factor. I'm going to cube root that, I think, to find the length. Yeah. So I'm going to start by working out the height of prism B. So I'll call that HB for now. And that's going to be equal to, well, if we go, the area of a triangle is equal to half AB. So the height, or half base times height. So the height would be equal to the area, 2 lots of the area divided by the base. So the area of, sorry, the height of B would be equal to 2 multiplied by 43.74 divided by 8.1. So I make the height of that to be 10.8. So now we need to work out the scale factor. Right, so the scale factor, so the volume scale factor is going to be, no, actually, we'll just go for it. The scale factor is going to be equal to the cube root of 1587.762 divided by 58.806. So that's going to be shift cube root of fraction numerator 1587.762 and denominator 58.806, and that gives us a very nice scale factor of 3. So the height h is going to be equal to 10.8 divided by 3. 10.8 divided by the answer that I just worked out gives me a value of 3.6. So there we go. Ooh, my 6 is dragged down. 3.6. Right. So marks for that then. Where do we pick them up? P1 is given for the process to find the scale factor of the volume of the prism. Okay, so arguably we pick up that first P1 there. And then we've got, where are we? P1 for working at 10.8. Processing mark for doing 10.8 divided by the cube root of 27, which would be that one there. And then A1 for the 2.6. There we go, perfect. Right, question 6. So the point L, M, and N are such that L, M, N is a straight line. The coordinates of L are minus 3, 1. The coordinate of M is 4, 9. Given that L to M, LM to MN is 2 to 3, find the coordinate of N. Okay, so let's do it like this. Let's say L, M, and N. So we've got the coordinate of L at minus 3, 1. We've got the coordinate of M at 4, 9. And we also know that the ratio between these is 2 to 3. So if we actually look at the distance between these 2 points, the difference between minus 3 and 4 is 7. So that's actually increased by 3.5. The difference between that is 7. So I'm going to do it like this. It's not overly well written, but we've got We want to do the difference between them, which is minus 3. No, sorry, other way around. I'm going to do 4 minus 3 divided by 2, and then I'm going to have to times that by 3. And then for my other coordinate, same process. This time I'm going to do 9 minus 1 divided by 2, and then times by 3. And that'll give me my x coordinate, divided by 2 to get one part, and then times by 3 to get 3 parts. So what that will actually give me, though, I believe, is the that'll actually give me how much bigger than minus 3 it is. We'll come back to that in a second. I'm going to scrap doing these coordinates and just call it difference in y and difference in x. So difference in x, and that's going to be the difference in y. So it will actually be this much bigger than coordinate m, I believe. So let's just do that for now. So 4 minus 3 is going to be 7 divided by 2. 7 divided by 2 times by 3 would give me 10.5. And then 9 minus 1 is 8, divided by 2 is 4. 4 times by 3 is 12. So that's actually how much bigger than this coordinate it would be. So what we've done is we've looked at the difference from there to there, and then we're going to say that what the difference from there to there would be. So the actual coordinate would be that plus 4 and that plus 9. So my actual coordinate would be 14.5 and 21. So n would be at coordinate 14.5, 21. So 14.5 and 21. Okay. Right. I'll put that just to make my workings clear, and we'll look at the mark scheme. So P1 is given for the process to use the coordinate to find the translation of L to M. They've gone, okay, yeah. So that is, it doesn't say whether it's for one or for both, but in effect, that's where my P1 comes from. And then P1 to give the process to use the ratio 2 to 3. So that's the divide by 2 part. And then P1 for process to find the coordinate and then add that onto either L or N, which is kind of that part there. And then A1 for, and they agree with me. Okay, question 7 then. In light of the shaded shape, a scale factor of -2 with a center of 0, 0. Okay, so that basically means when we're enlarging by a negative factor, what we're doing is we say, we look at the distance from there to there, and we say that it's going to be, so if we say that this is 3 to the left and 2 down, then it would go 6 to the right and 4 up, so that point alone would go to there. Then I can do that for all of my points if I needed to. So this one is currently 5 across to the 5 left, 2 down, so it would go 10 across and 4 up. This one is 2 to the left and 4 down, so it would go 4 to the right and 8 up. And we can get the shape from there, really. We'll carry on now. There we go. And then we should be drawing them with a ruler. I can't really do that very easily on here. But there we go. That will be my basic shape. And then I can double check any of the points using my ruler and just check that the coordinates actually all line up. And I could measure the distances. All the distances will be double. Right, and the mark scheme says, it's quite nice because it gives me the coordinates to check. So it says 6, 4, 10, 4, 12, 8, and 4, 8. So yeah, we're fine with that. So B2. And it does say, if not all correct, B1 is given for the correct size and orientation if in the wrong position, or 3 or 4 vertices correct. Okay, and question 8. Shop manager, gone too far. Shop manager wants to advertise special offer on social media platform. The manager asks 100 customers which of type A, type B, or type C they use. Okay, of these customers, 4 use all 3 types, 16 do not use, 8 use. Okay, so we're going to go right. So first of all, we're just going to try and fill in as much information from the question onto the page. So 4 like all 3 types, so that means that we have to have a 4 in the center of the Venn diagram. 16 do not use any of type A, type B, or type C, so 16 has to go on the outside. 8 use both type A and type B, but not type C. So the not type C is the big part there, so it can go 8 there. Right, 14 use both type B and type C. So type B and type C, but we already know 4 use them, so 10 must go there, because we already know of 4 of them in the intersection of the 3. 62 in total use type A. So I can't, well, I know that those 2 sections are going to add up to 62, but I can't put that in just yet. All 20 who use type C also use at least one of type A and type B. Use at least one of type A or type B, so nobody just uses type C, so 0 can go there. And because we're told that we've got 20, that means that this must be 6 here. And because of that, we can then do this one, as this currently adds up to 18, and it needs to add up to 66 and 62. So 62 take away 18 gives us 44 for our final section. And there we go, and there's only one section left to fill in. I'm just trying to work out whether there's a nice, easier way to do it. So I already know that all of that adds up to 20. So we've got 20 plus 44 plus 8 plus 16. That's what we've accounted for so far. So we must have a 12 left over there. And that's all my sections done. So, yeah, I'm just double checking that I've filled all sections. One of the customers is chosen at random. So the fact that it's chosen at random, given that the customer uses type A. One of the customers is chosen at random, given that the customer uses type A. I think that's quite badly worded. One customer is chosen at random, given that the customer uses type A. So that's telling us that the denominator should be 60. Also uses type B. So I think that that's going to be, we're picking from this circle, and we're trying to find the number that are in this circle. So I think it's going to be 12 out of the total number. So have we got a total for this already? We haven't quite. So 44 plus 10 plus 8. So we're looking at 62. So obviously we can cancel that fraction down to 3 out of 20, 31, 6 out of 31, sorry. Don't think we need to for that question, but I'm sure that that's right. Not one customer is chosen at random. That would normally be the statement that implies that you pick out of the 100, but it does say given that this customer uses type A. So I'm fairly sure that 62 is going to be the denominator, but I think that's quite a badly worded one. But there we go. Okay, let's check for the mark scheme. I'm just going to scroll and see whether they agree with me for that part B. They do. Right, so it is, for the Venn diagram, C4 is fully correct Venn diagram, and I can see that all of the sections, they agree with me, so I've got a C4 there. C3 if 6 or 7 or 8 regions are correct. C2 if 4, 5 or 8 regions are correct. And C1 for 2, 3. Sorry, I read that completely wrong. C3 for 6 or 7 of the 8 regions correct. C2 for 4 or 5 of the 8 regions correct. And a C1 for 2 or 3 of the 8 regions correct. Okay, and then we have got an M1, and it's just an M1 and an A1. There was no need to simplify the fraction, but that is fine. If you've not got the A1, but you've got 12 as your denominator or 62 as your, 12 as your numerator or 62 as your denominator, but not got the correct fraction, so you've got either your numerator or denominator of 12 or 62, you can still put up a method mark on that question. Right, question 9 then. So for question 9, we are looking, the graph below gives the volume in litres of water in a container t seconds after the water starts to fill the container. So we've got volume in litres, time in seconds, calculate an estimate for the gradient of the graph when t is equal to 17.5. So I've not got a ruler with me today. So what I'm going to try and do is, which I should do more often, but I'm a bit lazy. Let's just change that to the colour that I'm using. So I think I'm blue at the moment. Let's put that better blue close to my pen colour, and we'll go slightly heavier. That should work. There we go. Right, so I'm going to move this to when t is 17.5. So I'm trying to draw a tangent at that point there. So if I move my line around until I've got something that I feel happy with as a tangent. So that's not bad. I think it's going to be slightly more like that though. That looks pretty good. Let's just extend it to cover the whole graph. There we go. So I've got my tangent to the curve at 17.5. Now I just need to kind of work out the gradient of the rectangle, the triangle that's created from that. So if I'll go nice and big. So my change in y, I'm going from 0 up to, that looks like 15, 16, 17, 18. And then I've gone from, that looks like 5, 6, 7, we'll go real, 7.5 to 25. So we've gone up by 25 minus 7.5. 17.5. So my gradient is going to be 18 divided by change in y divided by change in x. So I'm looking at 18.5 divided by 18 divided by 17.5 gives me a value of 1.0285 ... So I'm going to go for 1.03. Okay, describe fully what the gradient of part A represents. So the gradient represents the rate of change of the volume. So the rate of change of volume over time. The increase in volume per second would be fine as well. So I'm going to go for that. The increase in volume each second. And have we got part C? No, that's it. So, right, we have got this mark is given for a tangent drawn at 17.5. So we've got, I missed, Okay, that's not helpful. Right. So we've got an M1 for tangent drawn. Pens line up. M1 for the tangent. M1 for method to find the gradient. So that's my M1. Let's clear that up. And then an A1 for my value here, but it says I can accept anything from 0.9 up to 1.2. And then for part B, this mark is given for a valid explanation. For example, the gradient represents the rate of change of volume over time. That's absolutely fine. Right, question 10 then. The shaded region shows, shown on the grid is the bounds of 4 straight lines. So I'm guessing we're going to have to write the 4 inequalities down. We are. Right. So what I'm going to do is I'm going to write down the equation of each of the lines first of all. So this is the equation of y is equal to 6. So the inequality would actually be, I want the section where y is less than 6. So y is actually, technically speaking, because these are full lines, not shaded lines, they can be equal to. So it should be less than or equal to 6. I'm sure there won't be an issue if you've not got the inequality symbol though. The correct inequality, the equals to as well. But it's good practice. This line, I'll do the next easiest one, is the line of x is equal to minus 3. So the actual inequality would be x is greater than or equal to minus 3. We'll do this line next. So we've got an intersection of, so y is going to be equal to mx plus c. C is going to be 6. And then the gradient, have we got a nice gradient here? Well, that point goes at minus 2. So if it goes minus 2 up 6, it's going to have a gradient of 3. And we would want the section where we want the section where this side is bigger, which would be y is greater than or equal to. So y is greater than or equal to 3x plus 6. And then my final equation, we've got a negative gradient. We've got an intercept of minus 1. So y is going to be equal to x minus 1. And the gradient of that is, well, we've got a coordinate there. So over that space of that coordinate, it's gone down 3 and across 6. So that's looking at half. So minus x over 2 or minus a half. And we want the section where, again, greater than. And always pick a coordinate to use as my checkpoint. Yeah, so that's right. So we're looking at also y is greater than or equal to minus x over 3 over 2 plus 1. Okay, just to double check that by putting a coordinate in. We'll go for that one, 4 minus 2. Does that work on that one? So I'm just 4 compared to minus 6 compared to 0. So yeah, that would work. And then 4 compared to minus 2. So yeah, that's right. Okay, let's go to the marks then. So okay, fairly straightforward. M1 for each. M1 for the first one being correct. It's saying M1 for the second one, expression with. Okay, sorry, actually M1, this mark is given for an expression with y is equal to 6 indicated. So an expression, so actually I can get the M1 over here. M1 is given for the expression with x is equal to minus 2 indicated. M1 is given for an expression with y is equal to 3x plus 6 indicated. And then A1 is given for 4 correct inequalities found, so A1. Technically speaking, that makes sense. The mark scheme is a little bit sketchy to check because they've got the working answer, the mark, and the note. I'll bring it over and show you. Mess things up slightly. So where are we? So there we go. So what it actually says is it has these inequalities for each one, and it has M1, 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 A1. But then in the actual notes, you can see what it says. The mark is given for an expression with x equals to 6 indicated. So it doesn't actually say that we need the inequality symbol for the mark. But it does say for the A mark, you do need all 4 inequalities. Okay, right. And bring my paper back up. Oops. There we go. And that was question 10, so I'll stop the video there and restart another one shortly.